These right here are my favorite factoring questions that I like to ask my algebra and pre-calculus students. First, we have x squared minus 64. Second, we have x squared plus 64. Third, we have x cubed minus 64. Lastly, we have x cubed plus 64. As you can see, they all look similar, but be careful. Now, you should pause the video. Try them first before you watch the solution. Done? Okay. Let's start with the first one. We have x squared minus 64. This is the difference of two squares, because we can look at this as x squared minus 8 squared, because 8 squared gives us 64. So if you factor this, you will just get x minus 8 times x plus 8. And we are done for that. However, before we go to number 2, because if you have an addition, this is the sum of two squares. Yes, right here you can say this is actually not factorable. I'll just say not factorable. Especially if you're just in the algebra class, then you just put on not factorable, you move on. Sometimes you may want to say not factorable with real numbers, then that's fine too, to be slightly more technical. But we'll come back to this later on. Because of course, if it's not factorable with the reals, what if we try it with complex numbers, right? But let's talk about that later. Now for number 3, notice that they are very similar, but if we have x cubed, then we will have to look at 64 as something to the third power. And the answer is 4. 4 to the third power gives us 64. So we will be looking at this as x cubed minus 4 cubed. Then when we factor this, let's try to write down the answer first, and I will remind you guys the formula later. We will get x minus 4 times square the x, so we get x squared, and then here is plus. There's no 2. It's not 2 times this and that. It's just x times 4, so we can write down 4x. And lastly, you take the 4 and you square that, which is 16. So this right here is the factoring formula. It's the factoring for that, and I'll show you guys the formula later. Now for number 4, notice that we have a sum, but when we have two cubes, this is actually factorable with the reals. Again, you will have x cubed plus 4 cubed. They are going to be very similar. You will get x plus 4 first, and then you will have x squared minus 4 times x, which is 4x, lastly plus 4 squared, which is 16. So that's that. Now, of course, I have more videos on how to factor the difference and also the sum of two cubes. The links will be in the description. You guys can go ahead and check that out for more practice. And now let me just remind you guys the formulas. For this one, well, let's write it down right here. A cubed, if it's a minus b cubed, this right here gives us a minus b times a squared plus ab plus b squared. And that's how we end up with this, because this is the a and this is the b. So that's how we get the x squared and then ab and then b squared, which is the 16. Now for this right here, a cubed plus b cubed, we will get a plus b times a squared minus ab and then plus b squared. Right? Very similar, but just be careful with the sign. Right? This is a plus and minus. Yeah. Alright, so finally let's do this one right here. This is not factorable with the real numbers, but what if we try the complex number, right? Well, to do so, we can purposely look at this as x squared minus negative 64, because minus a negative still gives us a positive, right? Now, here is the deal. Something squared is giving us x squared, which is just x squared, minus. Now we have to think about something squared that will give us negative 64. And the answer for that will be 8i. Not ai, but 8i. Because 8 squared is equal to 64, I squared gives us negative Yeah. So if you look at this now, you can factor it x minus 8i times x plus 8i. And again, you only do this if you are asked to factor this thing with complex numbers. And perhaps also write down the formula for you guys right here. A squared minus b squared. This right here is equal to a minus b times a plus b. That's it.